Alright guys, I'm going to shoot a video showing the connection going from electronegativity into Lewis dot structures and then into bond polarity. Okay? Then hopefully we'll be able to also start seeing some molecule polarity, but perhaps I'll save that for another video. Let's start with drawing an H2O. Okay, so we're going to learn how to draw the Lewis dots. First off, we need to be able to draw the Lewis dots for individual atoms. Okay, so to draw the Lewis dots, Lewis says we don't care about all those electrons, we really only care about the valence electrons. And we can tell how many valence electrons an atom has just by looking on the periodic table. I'm going to pull back up this periodic table that has this funky shape to it. To find the number of valence electrons, we just need to count in from the left. So if we wanted to put the dots on oxygen, we're going to find oxygen. Now we're going to count to oxygen from the left. So 1, 2, 3, 4, 5, 6. Oxygen has 6 valence electrons, so I'm going to put 6 dots on it. I can put them wherever I want, as long as I don't put anything paired up until I've got one on each side. I could have gone on any order. I didn't need to go in a counterclockwise circle or anything like that. Now I've got 4, I need 5, 6. I need 2 more, and I can put them anywhere, but now I'm full on each side, so now I'm going to start giving pairs. I can choose any side I want to be the pairs. Let's choose those two. Okay, so there's oxygen with its 6 dots. These two are unpaired. These two are, I've got 2 pairs here. So that's going to be important for us later on as we make a molecule. For a hydrogen, to find the dots of hydrogen, it is the first one on its row, so it's only got 1 dot. Ding, it's got 1 dot. So oxygen has 6 of its 8. Oxygen has 1 of its 2. So it's only 1 away from full, where oxygen has space for 2 more. Now, to draw a water molecule has 2 hydrogens and 1 oxygen. So first off, we need to decide who to put in the middle, oxygens or hydrogens. We're going to do the one that has the most unpaired electrons. This guy's got 2 unpaired electrons, where this guy's only got 1. These are the ones that do the bonding. The one that bonds the most time, we're going to put that in the middle so that it can bond that many times. So I'm going to redraw this with an O in the middle and 2 hydrogens around it. We'll put them here and here. We'll give them their dots, 1, 2, 3, 4, 5, 6. This guy gets 1, this guy gets 1. Now we're just connecting the dots. Those guys already have pairs, we're going to leave them alone. But this guy needs a buddy. Let's give him a buddy. This guy doesn't have a pair either. So they both need a pair, now they've got a pair. We're all bonded up. Every electron is now part of a pair. So there's our molecule. Now, let's do one more molecule, then I'm going to come back to that. So here we've got carbon, hydrogen, and fluorine. We need to decide which one to put in the middle, so let's give them each their dots. Carbon is the 4th one in on its row. Hydrogen is the 1st one in on its row. And fluorine is the 7th one in on its row. So we'll give it 7 dots. There we go. Now, to decide which one goes in the middle, we want to see which one has the most unpaired. This guy's only got 1 unpaired. This guy's only got 1 unpaired. This guy's got 4 unpaired. So we're going to put it in the middle. Carbon goes in the middle. So we'll put a carbon in the middle. And then we've got 2 hydrogens and 2 fluorines to put around it. So we'll put a hydrogen, hydrogen, fluorine, fluorine. There we go. Now we'll give them all their dots. This guy's got 4. This guy's got 7. Hydrogen's got 1 each. Okay, now we're going to pair things up. This guy needs to find a pair, so we'll bind in to that central atom. So that every electron is now paired up. So these guys were already paired, they're good to go. The one loner got a buddy. Alright, notice I bonded everything to that central atom, so I didn't end up with just two disconnected molecules. We want to make sure everything binds together into the center, so we've got one molecule. Now, I want to talk about bond polarity. Okay? Bond polarity, as we saw in that last video, was when there is a covalent bond. These are both nonmetals, but that covalent bond is between two things that are not an even match for each other. Oxygen is much stronger than hydrogen. As we can see here, oxygen versus hydrogen, oxygen is much stronger than hydrogen. Hydrogen's only about as strong as boron here. So the farther in towards the right you go, the stronger they are. Now, that means that the electrons being shared here between this oxygen and this hydrogen, they're not being shared evenly. They're spending more of the time over here next to the oxygen, so that side is going to be more negative, more of the electrons, and this side is going to have less of the electrons. It's going to be somewhat positive. So there's our bond polarity of this bond. And the same thing is going to be happening on this bond as well, that the electrons are going to be spending more time over here on the oxygen side and less time over here on the hydrogen side. So we have a relatively negative side of this bond and a relatively positive side of this bond. That lopsided bonding, that polarized covalent bond. We're going to see that happening over here on our second molecule as well. Carbon and hydrogen are pretty evenly matched with each other. Okay? So we said that that's going to be a non-polar bond. We could just leave that thing alone, right? Perhaps in some cases we might circle that to designate we can tell this thing is non-polar. Okay? Either way would be fine. What we really want to see is the polar bonds. Oh, I've smudged it all away. Okay, what we really want to see is between this carbon and this fluorine, fluorine is definitely stronger. Don't mind the jet flying overhead as we speak. So the electrons are going to shift more towards that fluorine and not so much towards that carbon. Okay, so we've got bond polarity shifting towards the fluorine and away from the carbon. So the carbon's going to be relatively positive, that fluorine's going to be relatively negative. Alright. Now, I want to talk about, there's two more things we need to talk about is molecule polarity, if a molecule has more electrons on one side than the other, and intermolecular forces. Okay?